By the end of this video, you'll be able to do WAN failover if you've got more than one internet connection using OPNsense. If you've got this far and you've obviously Googled this video or it's been suggested to you on YouTube, then I'm assuming you already know what OPNsense is. If not, take a look at my other videos. I have done videos on how to install it, and I say I'm going to cover a lot more. So with that, let's get started.
Sheridan Computers, IT, Communications, Support.
To give you a brief overview of what we're trying to achieve, we have our OPNsense firewall, and that basically has two WAN interfaces. So we've got our WAN 1, which is on 10.1.50.102. Ignore the fact that all the IP addresses are private. It's just the way I set up for this demo, so I'm not revealing any public IP addresses or anything. So our WAN 1 is on 10.1.50.102. Obviously the gateway is in line, so our ISP gateway is on 10.1.50.1. This 00 is just, obviously it'll pick a random IP address up. So with that, we've also got our WAN 2, and the IP address for that is 192.168.100.100. with the gateway for the ISP being 192.168.100.1. And again, we've just got 0000 because that'll be filled with whatever IP address is provided to us by our ISP. So the goal of both of these is to get us to the internet. And what we're trying to achieve here is failover. So by default, we want our traffic to go through ISP 1. And if for whatever reason that ISP 1 goes down and it's not available, then obviously we want all our traffic to go out of ISP 2, with the goal of obviously whichever ISP we're going through, we get to the internet and we get to example.com. So our example.com machine, don't try the things that I'm doing with example.com yourself. So I've changed the IP address of example.com, so you can see that resolves to 172.16.69.101. So that won't be reachable for you, and some of the tools that I use are not going to be available to you. So this is our internal system. That's why they're all on internal non-routable addresses. So we've set this up on one VLAN, and we've set this up on another, just so we can demo it with that. So our OPNsense firewall, the LAN side of it is 10.1.10.20. And we have our host 1 here. So host 1 is our internal computer system. So you could have like 5 of these, 10 of these, however many you want. But they're all going to have the gateway set to 10.1.10.20, which is our OPNsense. So with that, I hope it gives you an idea of what we're trying to achieve. So basically, we just want all traffic to go through here. If it fails, then we want all traffic to go through here instead. With that, let's switch over to OPNsense and take a look at that. Okay, let me just move this over here so you can see it properly. So you can see we've got our LAN address here, 10.1.10.20, which is what we've got on our diagram. We've got our WAN 1, which is 10.1.50.102, which is this one here. And then we've got our WAN 2, which is 192.168.100.100, which is this here. So our gateways are just on whatever the subnet is, .1, so 10.1.50.1, 192.168.100.1. And we can see those here. 192.192.168.100.1 marries up with that. And then 10.1.50.1 marries up with that. Just save this. Okay, so the first thing that we're going to want to do is just to check our DNS and system settings are right. So what we're going to do is head over to System and then just scroll down to Settings and select that. We want General. So once we're in General System Settings, I'm assuming at this stage you've got OPNsense up and running. So what we're going to do is set our DNS servers. So I'm going to change this to Google's primary DNS server, which is 8.8.8.8. And I'm going to tell that to use 1.1. And then I'm going to set another DNS server to 8.8.4.4 and set that to 1.2. So all traffic for 8.8.8.8 goes through 1.1 and 8.8.4.4 is Google's secondary DNS server, and we want that to go out of 1.2. There's an option here to allow DNS servers to be overridden. That's down to you, to be honest, in your settings. But as I say, I'm assuming you've got your WAN interfaces working. Allow default gateway switching. Since we've got two WAN interfaces, we're going to want to enable that. So we'll go ahead and just click save on that. And then just to test that both your WAN interfaces are actually working, if we go into interfaces, and then we want diagnostics, and then ping. I'm going to do a couple of ping tests just to make sure that both of the WAN interfaces are working properly before we continue. So for the host name or IP, I'm going to ping 9999, which is Quad 9's DNS. Leave the address family to IP version 4. Now the source address, I'm going to set it to 1.1, which was 10.1.50.102. So 10.1.50.102. Then we'll just apply that, and that's worked. So 1.1's working, and now we're just going to test 1.2 by changing this to the source address to 1.2, which is 192.168.100.100. So if we change that to 192.168.100.100, apply that. So that's worked. We've pinged 9999 from both of our WAN interface addresses, and they've come back with no problems. So it's a good idea to do that just to make sure you don't get any problems further down the line. I can remove these now, and with that, I'm going to head back up to System and Gateways, and then Configuration. So you can see this is where our gateways are defined. Now the only thing that I've done on this, because I've got two interfaces for the WAN, is I edited 1.1, which I'm using for my primary gateway. So click on the edit, and this upstream gateway, I have it ticked, as you can see here. This will select the above as the default gateway candidate. So I've got that ticked for my 1.1. By default, disable gateway monitoring is ticked by default on OPNsense for some reason. So we need to untick that. And then for the monitor IP for 1.1, I'm going to set the same to how we set the DNS servers. So we set the DNS server for Google's primary to 1.1, which was 8.8.8.8. And then we're going to save that. So that'll update itself in a minute. And then I'm going to go and edit the 1.2. Again, untick disable gateway monitoring. And then this time we're going to set that to what we set the DNS servers to go out of 1.2, which was Google's secondary, so 8.8.4.4. And we'll go ahead and save that and apply. So I just pressed F5 to refresh the page. Or you can obviously just click on refresh up here. So now we've got this right, and we've got our gateway monitoring set up. So like I said, make sure that you have the monitoring set up to the same as what we set up the DNS to. So in the system, where was it? Settings, general. We had Google's primary 8888 out of 11, which is the same as we've set monitoring up. So 8888 through 11. And then we had Google's primary 8844 going out of a 1.2. So just make sure that you've got them set right. As you can see here, I've got 8844. We've got that going out of 1.2. Right, so once you've got those set, again, under system and gateways, this time we want group just under configuration. So we're going to go ahead and select that. And this is where we can define gateway groups. So what we're going to do is set up a gateway group that's called untrusted. And we'll add both 1.1 and 1.2. So basically 1.1 and 1.2 become a combined gateway. So to do that, click on this add over here. And then I'm going to give it a group name. So I'm going to call this untrusted, because the one's untrusted. And when it comes up to setting gateway priority, now I'm going to do another video that covers load balancing with failover, but to give it away, it all boils down to gateway priority. Excuse me. So what we're going to do is set 1.1 as tier 1, which means that's preferred. And we'll set 1.2 to tier 2. So it means it'll try and use this 1.1 to send traffic by default, and then if it can't, it'll go to 1.2. If you had like 1.3, 1.4, then you'd obviously set them to 3 and 4. Trigger level, we're going to set to packet loss or high latency. So if we notice we get packet loss, then it'll automatically start changing the gateways. So I say I'm going to do another video on load balancing, but if that's what you're trying to achieve and you're watching this, then all you need to do basically is set this to tier 1. And sorry, tier 2. Once that's set to for failover, you trigger level, packet loss or high latency. Now pool options. So if we was using load balancing with them both set to tier 1, we'd select round robin with sticky address. Now we're doing failover, so we've got tier 1, tier 2. So what we want is just round robin. So round robin means that it'll try and say use this. If it's down, use this one. The sticky address for use with load balancing. Well, basically, if you've got like 2 clients on the network, it'll send one out one gateway, one out the other, and it'll just stay like that. So it's so HTTPS doesn't break and things like that. Now I'll cover that in a separate video, like I say. Now for this, we're just going to put the description as failover and then save that. So give it a group name. Untrusted is good because both WAN interfaces are untrusted. Whichever one you want. If you want 1.2 as your primary and 1.1 as your failover, then you'd set them that way around. So lowest priority wins. So 1.1 tier 1, 1.2 tier 2. Save and apply. So you can see now we've got our untrusted gateway, and both 1.1 and 1.2 are members of it. So now with that, the next thing that we need to do is adjust the firewall rules. So if we go down to, and just close that, head over to Firewall and head down to Rules. And then under our LAN rules, the default rules appear. So by default, anything from the LAN net is allowed anywhere. Now this, we want to edit this default rule. So this default allow all is the rule that we want to edit. And we're going to click the edit button and then scroll down until you find gateway. So it's set to default, which is, if you remember when we looked at 1.1, I stated that I'd set that as default gateway, which is what's used for OPNsense itself. And we enable gateway switching, so if it goes down, OPNsense can still access the internet. But now we want to change this to our untrusted gateway group. So what we're basically doing is telling, let me save that, and I'll apply those changes. So what we're basically doing is telling all LAN traffic to go through untrusted, which is failover. Now you could add another firewall rule in here if you didn't want all your traffic to fail over. For example, if you learn to speak, Sam, if you only wanted your servers to fail over, then you could set another rule up with your servers as an alias, and just have your servers fail over if bandwidth was limited, for example, on your secondary WAN. Or you can have it as we're going to do here, just allow default. We want everything to go through untrusted. So with that, let's head back to the dashboard. So I'm going to go up to lobby, dashboard. I'm going to drag this over. So this is our system that's on 10.1.10.15. Which, looking at our diagram, is this host here. Where's that gone? Come back. Our example.com, which is this host here. I have open in this window, and I've got iPerf listening on it. So if I do iPerf free -c example.com, so that's working. So obviously we can access it. And we can see that that came from 10.1.50.102, which is this address here. So that's the address of our 1.1. So what happens if this fails? Well, let's make sure it works. So what I'm going to do is, I'm using Proxmox here, so just to demonstrate the failover, so you don't need to worry about this. So 1.1 is on net 1, this one. So if I edit that and I disconnect it and click OK and switch back, so we can see 1.1 is now offline, and we can see the loss showing 10%. Status has switched to packet loss. Now it's offline. So even though it's offline, if I pull this back up, just clear the screen on that. Now do that again. So you can see that the that's now coming from 192.168.100.100. So that's failover working between two WAN interfaces. And if I go back in and I re-enable my WAN interface, say ignore the fact that I'm using Proxmox. So we can see now that it's showing online, and sorry, now you can see it's showing as online. I just refreshed that because we're still showing 1.1 is down, but the gateway was showing up. Right, so with that, let's see if it's switched back yet. And you can see we've switched back to 10.1.50.102. So the first time we did it, we got the reply from our 1.1, which is 10.50.102. When 1.1 went down, we got it from our 1.2 address. Now it's come back up. We've got it from our 1.1. That's pretty much it for failover. Now I did say I'm going to cover load balancing in another video, and I will. But since we're here, we might as well do it. It doesn't take much to configure. So what I'm going to do is go back into our gateway groups. So I headed into system, and then gateways, groups, and I'm going to create another one. So I'm just going to hit the add button. I know we're already using them here, but we're just going to add another one. So we'll add another one in. Set this group name to load balancing. And as I mentioned before, this time we want to set both the 1.1 to tier 1 and want to set the 1.2 to tier 2. We're going to change this trigger level to packet loss high or high latency. And as I discussed before, we need to set round robin with sticky for this. And we do OK to that. We apply those changes. And they all show offline. Press F5 or refresh your browser and they'll all come back online. So now you can see it's slightly different. Where the untrusted shows tier 1, tier 2. So that's primary and failover. This time we've got load balancing, and you can see that they're both on the same line. So now, if we go back into Firewall, rules, and then LAN. And this default LAN rule that we set to untrusted, we're going to go and edit that. And then scroll down to gateway. But this time I'm going to set it to load balancing. And save it. And apply those changes. So now what will happen is, where's my thing gone? This time, if I do iperf3example.com minus p2, so it's received two streams from 192.168.100.100, and that's what we wanted. We wanted both streams to go from the same interface, because if you visit a website and you fill in a form out or whatever you're doing and you submit the form, you might get a different IP address, and that's what the sticky does. So where was it? Under gateways. Where's gateways? System, gateways, group. I'm just going to edit this group that we set for load balancing, just to demo what this does. If I set that to round robin, then apply those changes. Again, just refresh the page. Now what we should get, and just clear this. That's not going to work. Now you can see that they split. So we've got one stream going out of 1.1 and one stream going out of 1, 2. I'm going to say if you do load balance that way, it's likely to break on a lot of sites. If you visit a site, generally when you log in for security reasons, if they're done right, it should bind that to your IP address. And if your IP address changes when you start visiting the site, it's going to break, especially on things like banks or anything that's HTTPS. So I was just demonstrating it. So I might do another video on it. I'm not sure if there's much point. So gateway groups, we're going to edit it and set this back to sticky address and then save that and apply those changes. Refresh that if you're as impatient as I am. And then when we do that again, you can see that everything's now coming from 1.1. So with that, it doesn't push everything through 1.1. It'll push devices through. So if you have like 5 computers, it'll randomly split in between 1.1 and 1.2 and keep it that way. So that's a good thing to just keep in mind if you want to do load balancing. This load balancing option with the sticky address, if you want to change the default timeout of that, let's say if you're filling a form out, I don't know, if you're filling a credit application form out or any type of long form, it's going to take 10 or 15 minutes for you to fill out, 20 minutes, then you might want to adjust that. And you can do it by taking a look at the firewall rules. So if we head over to firewall rules, so firewall settings advanced, and we scroll down to multi-WAN. So use sticky connections is ticked. This source tracking timeout is what you can set it to. So let's set it to 5 minutes and 300, 10 minutes, 600. If you want to set it to an hour, if you think that's sensible, set it to 3,600. The last thing you might want to check is on the NAT outbound. If this is set to automatic outbound rules, then you're not going to need to do anything because it's automatically going to create these for you. So you can see we've got NAT rules set for 1.1 and 1.2. Just keep that in mind, because if you set to manual outbound NAT rule generation and you only have them set up for 1.1, then you're going to need to add them in for 1.2 as well. The last thing I'm going to cover on here, if we go back into system and gateways and configuration. Now under these, where we've got our 1.1 and 1.2 gateways, we set in under group edit, we set this option here for trigger level, packet loss or latency. Under most circumstances, the defaults will be fine, but if you want to fine tune this yourself, if you go into configuration and then edit either of your gateways, if we toggle this advanced mode up here, so you've got gateway priorities, which basically just means choose a value between 1 and 255, influences the sort order when selecting a default gateway. Lower means more important. This way, if we set that to, what gateway we're on here? If we set this to, we're on 1.1. So if we set that to 2 and 1.2 was 1, then it would mean twice as much traffic would go over 1.1 than 1.2. I set it to 4, and then obviously 4 times as much traffic could go through. So you know, if you've got a slower connection and you want to balance it out a little bit more, You can do that with the wait. Wait for the gateway used when using a gateway group. And the packet loss, you can adjust here. So the latency and packet loss, if you want to fine tune it, you can do that under here. So that's in milliseconds, and the default's 500. So if you have a bit of a dodgy connection, you want to increase it a bit, you can do that in there. I think the data length is for when you sending keep alives and pings and things, just to make sure the gateway is available. So under most circumstances, you'll be fine to set it. Just leave the defaults. I just wanted to show you that the advanced section is there if you wanted to change it. I think I've covered pretty much everything. Defaults should be fine in most cases. I just wanted to show you how you can change the weight so that more traffic goes through one over the other, because in most circumstances when you've got this, your connections won't be the same speed, so it's sometimes handy to do that. So if one's twice as fast, if one's twice as fast as 1.2, you can adjust that here. But obviously clicking this full help up here, we'll toggle full help on so you can see what all the settings do for you. Let me switch this back over. I hope that helps if you're looking to set up load balancing on OPNsense. So just let me just switch back to this 1 second. When we went into Firewall rules and LAN, as I mentioned, we've set this gateway here and I changed it to load balancing. So you'll notice when I went into gateways, which is under system, gateways, configuration, sorry, group, we've got both of them in there. So when you go into your firewall rules, LAN, you can set up multiple groups. So we changed this to load balancing. If we wanted to switch it back to failover, then we can go back down to the gateway and we can change it back to untrusted. I probably should have called that failover for when I was doing this, but I weren't really planning on covering load balancing as well. So just keep that in mind. You can set like an alias up for your servers. So if you wanted your servers to load balance, then you can do. If you want servers to failover, obviously load balancing does work as failover as well. In fact, when we go to gateway groups, wrong one, system, gateways, group. So I've set untrusted, which is just the failover. We've got the load balancing one. Now what I normally do is set a couple of groups up. I did this in the PFSense video that I've just done. So what I'll normally do is prefer 1.1, set a description as prefer 1.1 fail to 1.2, and then you can do obviously set it that way. So whichever you've got prefer 1.1, so we've got prefer 1.1 preferred. And then save that, and then obviously we can add another one, prefer 1.2, so you can set 1.2 as primary. Again, change that to how you prefer. Packet loss or high latency is what I generally set it to. So I prefer 1.2 fail to 1.1. It's completely up to you how you set all them up. But having them set like that just gives you more customization over what you do. So you can have some like systems to prefer WAN 2, some systems to prefer WAN 1, just some to do straight load balancing, some to do failover. You can set the rules up then basically to do whatever you want. So if you don't use them, it's not going to cause any harm to the system. I'll just refresh that page so they're online. But yeah, let me switch back again. So yeah, if you found that useful, please like this video. It does help support the channel, and it helps that YouTube algorithm suggest it to people. Consider subscribing to the channel. I am planning on doing a lot more OPNsense videos. I'm already covering pre-FSense, so I am going to cover OPNsense as well, a lot more. So subscribe if you're interested, and if you hit the notifications icon, you might get notified about the videos as they are released. So I'll see you in the next video. Thank you for watching.